Today for your lecture, we're going to talk about ionic size and electron negativity. Then we're going to talk about the size of cations, positive charge, and the size of anions, negative charge. So Unit 5, Periodic Trends, Day 4. Ionic size and electron negativity! So, cations, they're positive and are always smaller than the neutral atom from which they are made. Sometimes there is a loss of energy level, and that depends on what energy level you're at and how many electrons you have in that energy level. And of course, there will be more protons than electrons when you are a cation. And why is that? Because you take away an electron, you become a cation. You are positively charged because you took away a negative charge. And what that means is those electrons are now pulled even tighter and even closer into that nucleus because there are more protons than there are electrons when you become a cation. So, the more electrons lost, the smaller the ion becomes. Because the more electrons you take away, which means you're taking away negative charge, which means you have an overall positive charge, the smaller you will be because those positive protons in the nucleus are pulling even tighter. They have more power now than the electrons because there's less of them, less of the electrons, and it makes a smaller atom size. So, an example, magnesium, neutral magnesium, is larger in size than magnesium plus 1 and definitely larger in size than magnesium plus 2. Or look at it the other way. Magnesium with a plus 2 charge is smaller in size than the neutral atom of magnesium. So, anions, negative, are always larger than the neutral atom from which they are made. So, opposite of cations. For the same reason. Well, for this reason, there's more electrons than there are protons. And that means there's less attractive force from that positive center to the outermost electrons. Why? Because there's more of them, more of those electrons. Because you gained a negative charge. You gained an electron. So the more electrons gained, the bigger the ion becomes. The less attractive force between those electrons and that positive proton nucleus. So let's look at an example. A neutral oxygen atom is smaller in size than the -1 oxygen atom, and even smaller in size as compared to a -2 charge oxygen atom. So, electron negativity and the trend on the periodic table. First off, what is electron negativity? That is the tendency for an element to attract electrons when chemically combined with another element. But I want to say that again. The tendency for an element to attract electrons. Electron negativity. What are electrons? Negatively charged. So electron negativity is the attraction force that the atom has for other electrons. Fluorine has the highest electron negativity at 4.0. And why is that? Well, let's talk about electronegativity first. The group trend. So you're going top to bottom or bottom to top on the periodic table. The electronegativity decreases as you go down a group. Electrons are less attracted to the nucleus as you go down a group. And why is that? Because you're getting further and further away from the nucleus. Because atomic size increases as you go down the periodic table, down a group. Let's talk about the period trend. Electron negativity, which is left to right, by the way. Electron negativity increases as you go across a period. I wonder why. The electrons are more attracted to the nucleus due to increased nuclear charge. And what does that mean? They're getting smaller. Atomic size is getting smaller, which means those electrons are getting closer to the nucleus, where the protons are. There's more attraction to them. So let's look at these values. Going from left to right, we have an increase in electron negativity, and going top to bottom, we have a decrease of electron negativity. So the atom with the most electron negativity is fluorine. Then a close second and third place is oxygen, chlorine, then nitrogen, and so on. And this has to do with the size of the atom, because those electrons can be closer to the nucleus. And fluorine happens to be the smallest non-noble gas on the periodic table, which means fluorine really wants to gain an electron so it can look like neon. Notice how there are no noble gases here for electron negativity. Why? Because those noble gases don't want any electrons at all. None, zero, zip. Why? Because their outermost shell is already filled with electrons. They're happy. Happy as can be, just prancing down the street, rubbing it in everyone else's face. That's what a noble gas is. So, in summary, an easy way to remember what electron negativity is the upside down snowman. And our really angry dude, I suppose, because you stole his Honey Nut Cheerios, or maybe you took a bite in its toasted cheese sandwich, is now in, I don't know, Alice in Wonderland, because snowmen are upside down. But when you knock over the snowman, because you karate chop him in the gut, he falls over this way. And let's look at the periodic trend. You'll have a higher electron negativity at the top of the periodic table, and it decreases as you go down. And then you'll have a smaller electron negativity on the periodic table when you increase from left to right. So small, getting bigger, having a higher electron negativity from left to right. And from top to bottom, you are big on top and small on the bottom. So an upside down snowman is how you can remember that. So go ahead and start worksheet 4.